Guys, welcome back sa aking channel. Ako nga pala Sir Mar Santa Maria, Master Teacher 1 of Governor Luis A. Ferrer Jr. East National High School, na magbibigay sa inyo ng mga math techniques para mapadali ang topic nyo sa mathematics. So ngayon, pag-uusapan naman natin kung paano ba tayo mag-analyze, mag-interpret, and mag-draw ng conclusions from graphics and tabular presentations. This is under MatheMARteknix 7, quarter number 4, and ayun, last week na tayo, week number 8. So try natin itong word puzzle kasi nagustuhan ko ito dahil mayroong integration sa ibang learning area. Okay, so sa number 1, it is blank deviation of a set of scores is calculated by computing the mean and the specific distance between each score, and that mean without regard to whether the score is above or below the mean. So ang tawag natin dyan ay average deviation or the mean deviation. But since ang word puzzle natin ay nagbibigay ng 1, 2, 3, 4, 5, 6, 7 letters, kaya gagamitin natin ay average deviation. For the third one across ay blank deviation is the measure of variation of the set of data in terms of the amounts by which the individual values differ from their mean. So ang tawag natin dito ay standard deviation. Ito yung karaniwang ginagamit talaga kasi ito yung higher form of deviation na ginagamit natin. Next, for number 4, it is generally considered the best measure of central tendency and the most frequently used one. Siyempre, it refers on the mean. Then number 5 is the middle value in the set of data arranged in increasing or decreasing order. So we have the median. Pagdating naman sa down, it's the difference between the highest and the lowest. Siyempre, is about range. And pagdating kay number 4, down is the most frequently occurring number of score in the dataset. It refers on the mode. Okay, so pag nag-analyze at nag-interpret tayo ng statistical data, kailan ba natin gamitin ang measures of central tendency? Ano ba yung natawag nito? So, review muna natin. So, when we say measures of central tendency are numerical, descriptive measures used to describe the center, okay? Kaya nga central of the given set of data. So, meron tayo ditong mean, median, and okay, mode. Pag sinabi naman nating mean, it is the most reliable. It is used when the data are of the interval or ratio scale. The median is generally used when the data are of ordinal scale. Samantalang ang mode naman natin dito are commonly used when the data are of nominal level. Okay, so review muna natin na tawag natin the levels of measurement. So meron tayong 4. Ang pinakamababa dyan is only nominal because the data can only be categorized tulad ng gender, ng birthplace. Kaya pag sinabi naman nating ordinal, the data can be categorized and at the same time it can be ranked. So halimbawa, top 5 Olympic medalist. And then ang next natin dito is the interval. The data can be categorized, ranked, and evenly spaced tulad ng test scores. Pero ang pinaka-highest natin dito is the ratio na kung saan the data can be categorized, ranked, and evenly spaced and has a natural zero. Ito yung pinagkaiba ng interval. Ang interval ay no natural zero, samantalang ang ratio ay with natural zero tulad ng height, ng weight, at ng age. Yung age natin, hindi lang whole number yun. Halimbawa, pwedeng 3.5 years, mga ganun, o kaya 2.75 years, ganun ha. So, kasama din syempre yung natural zero. At kailan naman natin ginagamit ang measures of variability? So, these are the measures of the average distance of each observation from the center of the distribution or the mean. The goal for variability is to obtain a measure of how spread out the scores are in the distribution. O yung natawag natin kung ito ba ay naka-scattered or naka-compressed. So, syempre, ang range natin dito, highest minus lowest, and then ang average deviation naman, it is the average value by which any value in the set of data or distribution differs from the mean. Tapos yung variance naman natin, average, ito nakascore na yung deviation natin dito. Then standard deviation is only the square root of the variance or determines the location of every value in the set of data related to the mean, and it is the most important and the most applied measure of variability. So, standard deviation is also used to compare two sets of data. So, dito naman sa drawing conclusions from graphic and tabular data and measures of central tendency and variability. So, una, how to make conclusions from the graphs. Una, look carefully at any horizontal or vertical scale that is given. Then number 2, consider each graph or chart separately. Do not compare them unless you are sure that they have the same scales. Then if it is not easy to interpret the graph or chart, try reading of some values. Lalo na kapag ang given natin ay naka-line graph or naka-bar graph, ang hirap minsan i-identify doon ng pinaka-exact value. Okay, so let us give examples of graph. Ito yung line graph, ito yung bar graph, but we have the same kind of data. Kaya nga, ang tanong natin dito, what data does each graph above show? So makita natin, ito na yung pinaka-title niya. So it is about what? It's about Olympic winning times in the 400 meter hurdles of the men and the women. So, alin kaya dito sa dalawang to ang madaling i-analyze? Ito bang line graph or ito bang bar graph? So, identify natin ngayon ang advantages o kaya advantage ng bawat graph. Okay? So, pag ginamit natin yung pinaka-line graph, can give quick analysis of the data. So, papasin natin dito, in 2005, medyo mataas yung time, di ba? Pero unti-unti bumababa, pero bilang tumaas ulit, tapos sa kabumba. So, pagka-trend pinag-usapan natin, mas magandang gamitin yung pinaka-line graph. Okay? But, sabi dito, according to sa nakalasulat sa inyong list, you can quickly tell the range as well as if there are any gaps of the cluster. So, I doubt it kung madali ba talaga hanapin yung pinaka-range. Halimbawa, dito yung pinaka-highest, hindi kasi natin ka-identify kung ano ba talaga exact value ng itong nasa 2005 na to, di ba? Di ba? Hindi natin ang hirap, ang napakahirap i-identify. Dito ganun din, ang hirap i-identify din ang pinaka-exact time. Diba? So, kaya, I doubt it na madaling hanapin yung range dito. Pero makita natin yung pinaka-trend ba dito kung bumababa, tumataas, ito yung gagamitin natin. So, this also means that it can easily observe changes. Yun na yun. Changes over a certain period of time. So, proceed tayo dito kay line graph. Pero yung bar graph, on the other hand, summarize a large amount of data in a visual and easily interpreted. So, makita natin dito, kita natin in 2015, mas mataas yung time ng girl, ng women kay men, ganun din, halos pare-pareho, di ba? Okay, so yun naman yung advantage ng pinaka-bar graph. So what is the disadvantage of each graph? Okay, the disadvantages are in plotting too many lines over a graph makes it cluttered and confusing to read. Lalo na siguro kung maglalagay pa tayo dyan, meron ko pa ganyan, di ba? Ayan, pag ganyan magiging graph natin. Sa labat na, napakahirap ng basahin pag ganyan. Yung bar graph naman require additional written or verbal explanation, can be easily manipulated to give false impression. Kasi dito, ang hirap talaga identify kung saan ba talaga exactong value tumapat yung pinaka-time natin yan. So, ganun din naman dito sa pinaka-line graph. Talagang mahihirapan tayo. Tulad mamaya, mahihirapan tayong makuha talaga yung pinaka-exacto. So, which graph would you choose in each case? So based on the given examples, it is easier to identify the trends using a bar graph, and it is easier to identify the relationship in a data. Ito yung nakalagay sa inyong list. Pero pagka trend ang pinag-uusapan, mas magandang gamitin itong line graph. Pero kapag relationship, makikita kagad talaga natin itong bar graph. Siyempre, makikita natin kung sino ba yung mas mataas doon, di ba? Yung sa women ba or sa men ba? Pero kapag trend ang pinag-uusapan, halimbawa, yung number of COVID cases, mas magandang gamitin yung line graph para makita ba natin kung tumataas ba or bumababa ba yung number of cases. Kaya pag itong trend na to hindi bar graph ha. So pag trend ang magandang gamitin ay line graph. So itong number 5 na to, natawa ko sa tanong na to, kay based on the given graph, who among them won the most? Ito yung nakalagay sa inyong list. This is mali ito. Okay, tapos sinagot pa nang by just looking at the graph, women won the most. Okay, kasi tinignan niya dito, mas matataas yung sa babae, di ba? Okay, kaya mataas sa babae kasi nga ito ay time. Okay, winning time. Siyempre, kapag the greater the time, mas mabagal. Siyempre, mas mabibilis ang mga lalaki kumpara sa mga kay babae. Kaya dito makita mo, mas taas talaga yung time niya kasi mas mabagal yung babae. Kaya approximately in 2005, ang time niya siguro mga nasa 55 seconds. Samantalang yung babae, yung lalaki naman ay mga nasa, sabihin natin ay mga 48 seconds, mga ganoon. Pero may mga decimal pa yun eh. Tapos in 2020 nga, parang 2018, tama, 2020, parang 51.9 ang pinaka-record ng babae na dun sa 400 meter hurdle. Kaya mga nandito yan, ayun. So, almost nasa 50. Kaya nga sabi ko sa inyo dito, napakahirap i-identify kung ano ba talaga exact data. Kasi lalo dito, pinag-usapan dito mga 51.9, ganyan, di ba? 51.9. Kahit ka dito sa pinaka-bar graph, ang hirap mo identify kung ano ba yung pinaka-time natin. Tapos, pag gumamit naman tayo ng frequency distribution, analyze natin itong 20 learners in the achievement test. Siyempre, ang magiging n natin dyan ay, ang I natin ay 7, 30 minus 23 is equal to 7. Tapos yung n natin dito ay 20. So, meron tayong last ng cumulative frequency. Paano makukuha yun? Starting from the lowest class interval, ito yung 1, plus 1, 2, plus 1, 3, plus 2, 5, plus 2, 7, plus 5, 12, plus 2, 2, 14, plus 4, 18, plus 1, 19, plus 1, 20. Pag naman greater ng cumulative frequency, starting naman sa pinaka-highest frequency, i-add mo naman yung mga frequency. Ito yung 1, kaya plus 1, 2, plus 2, plus 4, 6, plus 2, 8, plus 5, 13, plus 2, 15, plus 2, 17, plus 1, 18, plus 1, 19, plus 1, magiging 20. Mas madali siyang i-analyze kung lalagay tayo ngayon, ito nating lower boundary o kaya naman ng upper boundary. Ito yung pinaka true limit natin. Pag minus ka lang dito ng 0.5, kaya 85.5, minus ng 0.5, kaya 78.5, hanggang 23, minus ng 0.5, magiging 22.5. Pagdating naman kay upper boundary, mag-add naman tayo dito ng 0.5, kaya magiging 92.5, ito plus 0.5, magiging 85.5. Pagdating dito, 29 plus 0.5, magiging 29.5. Para madali nating ma-analyze ngayon, ano ba itong tanong na to? So, what interval contains the median? Okay? So, pag sinabi natin median, syempre, n divided by 2, di ba? Actually, n divided by 2, okay, magiging 20 divided by 2, magiging nasa 10th score. Kung nasa 10th score, tingnan mo lang ngayon pinaka last ng cumulative frequency. So, ibig sabihin, itong nasa 58 to 64 na to, ito yung nagpapakita ng, so since ito ay 7, ibig sabihin, ito ay nagpapakita ng pang 8 okay, pang 8 to at 12. Nakapaloob ngayon, yung 10th score natin dito kay 58 to okay, so 64. So therefore, the interval 58 to 64 contains the median. So in order to answer this second question, suppose the passing score is 51. How many students fail in the achievement task? Ang titingnan mo dito, yung upper boundary. So mapapansin mo, eto ngayon ang less than 51. Tapos tingnan mo naman ngayon, ang nasa less than cumulative frequency, katapat niyan, meron tayong 5. Diba? So ito yung kasi less than tayo diba? Pero ang kakatumbas ng less ng cumulative frequency ay yung upper boundary. Ang katumbas naman dito ng greater than cumulative frequency, ito namang lower boundary. Pag in-interpret natin yan, ang ibig sabihin ng 5, there are 5 students who got less than or equal to 50.5 na less than din sa pinaka 51. Unfortunately, they failed. Sayang naman Kaya therefore, there are 5 students who failed in the test that lies in the interval 44 to 50. Ayan, makikita mo dito katapat niya, kaya nasa 44 to 50. And the next, how many students naman daw dito passed in the achievement test? So, pag i-analyze muna natin ito, tapos bibigyan ko kayo ng pinakamadaling paraan. So, syempre, pag naman passed, ibig sabihin, greater than. Diba? So, sabi natin, 51 and above to, diba? So, greater than or equal to 51 tayo, kaya naman 50.5. So, tingin ka naman dito kay LB, lower boundary. Tapos, tingin ka naman dito kay greater than cumulative frequency. Ito naman to, di ba? Ang ibig sabihin kasi ng 15 students who got greater than or equal to 50.5. Which is, syempre, 51. Wala namang 0.5 na sa achievement task. Kaya, nasa 51 yon. So, ibig sabihin, there are 15 students who passed the test. Pero, syempre, pinakamadali, ang total natin ay 20. Ang bumagsak ay 5. Syempre, ang maritira dyan ay 15. So, ganun lang kadali yung number of students who passed the examination. Pero, ganun yung pag-a-analyze kapag ang gamit natin ay frequency distribution. Halimbawa, itong 6 na to, ano ibig sabihin? There are 6 students who got greater than or equal to 71.5. Halimbawa, ano ibig sabihin ng 19? There are 19 students who got greater than or equal to 29.5. Ano naman ang ibig sabihin ng 2 dito? There are students who got, ito palang 5. There are students who got less than or equal to, ito naman, 50.5. So, halimbawa, ano ibig sabihin ng 20? There are students who got less than or equal to 92.5 kasi ang pinaka-highest mo lang naman talaga ay 92. So, ganun yung interpretation ng cumulative frequency na kung saan pag less than, ang gagamitin sa upper boundary. Pag greater than, ang gagamitin naman ay si lower boundary. So, let us consider this example. Okay, Scheidel and Leidel have the following scores: means and standard deviation in their mathematics test. So, tingnan natin, pareho ang mean pero may kaiba ng standard deviation. So, ang standard deviation ni Leidel, ang taas 11.05, samantalang kay Scheidel is only 3.89. Patanong natin dito, who is more consistent in her performance? Ang sagot si Scheidel. Bakit? The two have the same mean score of 88.86, but to determine who is more consistent in their in her performance, we should use the standard deviation of the two sets of the scores. So since Scheidel score have a lower standard deviation than Ladel score, this means that the scores of Scheidel are more closer to the mean compared with a Ladel score. Ibig sabihin, kay Scheidel ay more compressed, samantala kay Ladel ay more scattered. Kaya si Scheidel ay more consistent in her performance than Ladel. Bawa kahit nga range ay kaya nating identify. Bawa ang range ng kay Scheidel is 95, okay, minus ng 84 magiging equal kay 11. Samantalang ang range ni Ladel ay 99, okay, minus ng 70 magiging 29, di ba? Mapapansin mo, yung pinaka best performance niya is 99 pero ang pinaka least performance niya naman ay 70. Ang layo, di ba? Kaya talagang kay Scheidel ay compressed, samantalang kay Ladel ay scattered. Okay, so punta na tayo ngayon kay learning task number 1. So use the bar graph to answer the questions that follow. For number 1, how many students ride in their bicycle to the school? Ito yung sa bicycle natin. So mapapansin hindi sakto, no? So hati-hatiin natin. About 25, 26, okay, 27, 28, okay, 29, 30. Okay, so meron tayong 29 students. Then pangalawa, how many more students take the jeepney to school than take the car? So sa jeepney natin ito, halos mga nasa 39 na yan. Okay, tapos ang car naman natin nandito mga nasa 9, kaya 39 minus 9 is equal to 30 students. Okay, so for number 3, how many students ride in a car in the school? Nasagutan natin yan sa number 2, so there are 9 students. And for number 4, how many students take the tricycle and walk to school combined? Ang tricycle natin dito mga nasa, sabihin natin 34, okay, tapos ang walk to school naman natin mga nasa, sabihin natin ay okay 19. So pag in-add natin ngayon ang 34 plus 19, so there are 53 students who take the tricycle and walk to school combined. Okay, so number 5, how do most of the students get to the school? Ito yung pinakamataas natin dyan. Sabihin, they are riding in a jeepney. So yun guys, kung may natutunan ka sa video na to, paki-like naman at paki-share sa iyong mga klase at don't forget to subscribe at paki-hit mo yung bell all para kapag in-upload ko yung learning task number 2 hanggang assessment sa week number 8 ay mabilis ka na mo notify. So thank you and God bless.